Okay, these notes are for Algebra 3 with trigonometry. We're on Unit 2, Section 1.5, Quadratic Equations. This is a very long section. It entails quite a bit. Some of it is new to some of you. So I'm going to go a lot slower at this section here. I'm going to split these notes up into two different sessions. This first session, we just talk about what a quadratic equation is. So it's a second degree polynomial. It's in the form ax squared plus bx plus c. A graph of a quadratic function would be a parabola, and we'll do more with this later on. Quadratics are important because they model a lot of real-world situations. So depending on what you're going to do after this course, you might see quadratics quite a bit. There are 4 different methods to solving quadratic equations. In Algebra 1 and Algebra 2, you learned about solving by factoring. Another method is the square root property. You're usually taught that method. You don't remember it. I can show you that easily. We're going to solve by completing the square. For most of you, this is going to be a new technique. It's not difficult, but you do have to be careful at each step. And then you should have been taught quadratic formula in Algebra 1 and once again in Algebra 2. And using a quadratic formula is important. So today's lesson, I'm going to focus on solving by factoring. So there are some certain steps that I always follow, and if you don't follow these steps in this order, you could possibly get the answer wrong. So my first step is I'm always going to write the equation in general form. And this book says general form. It's just ax squared plus bx plus c equals 0. Some call that standard form. Then we're going to factor it completely. The equation has to be factored completely, and it has to be factored correctly. So I always double check my factoring before I move on. Then we're going to apply the zero product principle. What you know this as is just set each factor equal to 0 and solve. And then most important to me is that you check your solution to the original equation and make sure that you've done it right. So my first example, this 3x squared equals 12x. I need to write it in general or standard form first. So ax squared plus bx plus c equals 0. So I always keep the x squared term positive. I'm going to keep this 3x squared on the left side, subtract 12x, set that equal to 0. Notice a is 3, b is negative 12. I don't have a c value, and that's okay. This one I'm going to factor using greatest common factor. From the 3 and the 12, I can remove a 3. X squared and x, I'm going to remove an x. Now I checked this to make sure I factored it correctly. 3x times x will be 3x squared. 3x multiplied by negative 4 is negative 12x. This is when I now use the zero product principle, which means I'm just going to set each factor equal to 0. If 3x equals 0, then x has to equal 0. If x minus 4 equals 0, then x has to equal 4. And there are many ways that you can check this. I like the graphical approach, but what you could do is you could go back to this original equation, and that's what these directions tell you to do. So I could go back to 3x squared. So 3, I'm going to put a 0 where the x is and square that. And I get 0, and then I have the 12, and I put a 0 where the x is. And they each equal each other. I could do the same thing with the 4. So I'm going to be a little bit lazy. I'm going to come up here, highlight that equation, change that to a 4, and hit enter. I get 48. Come up here to this equation, replace the 0 with a 4, and I get 48. So this is when I put a box around my answers, is when I know that I've done them right after I've checked them. My second equation, I have 7x plus 15 equals 2x squared. I get a lot of students who just decide to go ahead and take this 2x squared and subtract it, and you're going to end up with a negative 2x squared. And there's nothing wrong with that. But in order to do that, you're going to end up having to factor it a little bit more complicated. So I'm going to keep the 2x squared positive, and I'm going to subtract the 7x, and I'm going to subtract the 15. So I would end up having is 0 equals 2x squared minus 7x minus 15. If you feel it's weird having a 0 on the left-hand side, we can rewrite this. So now I need to factor this, and that's why we spent time factoring before. So for this video, I'm not going to spend time factoring. I'm just going to go ahead, and as I think of this, I know that I've got 2x and an x gives me 2x squared. I know I have to have a 5 and a 3, but I don't worry about the 7 yet. I'm purposely going to factor this wrong. I put the 5 here, and I put the 3 there. One's going to be plus, one's going to be minus. I'm just going to arbitrarily choose. So I get 2x squared plus 6x minus 5x. Plus 6 minus 5 is a positive 1. That's not it. So I'm going to change my 5 and my 3. Now I have 2x squared plus 10x minus 3x. Plus 10 minus 3 is a positive 7. I want a negative 7. So that means I need this to be a negative and this to be a positive. Now I check it one more time. 2x squared minus 10x plus 3x, give you my negative 7x, and 3 times negative 5 is negative 15. I set each of these equal to 0. Subtract 3, divide by 2, I get x is equal to negative 3 halves. Add 5, I get x is equal to 5. Now I can show you, and I could go back and do it the way I did it before, plug in the number in. I'm going to show you where I like to graph it. To me, sometimes a graph just makes it easier. And since you've all had this before, it might make a little bit more sense to you. I'm going to take this equation, 2x squared minus 7x minus 15, and I'm going to graph it. Since it equals 0, that means it's going to cross the x-axis at negative 3 halves and 5. This looks like negative 3 halves, but I'm going to check it. So second trace, I'm looking for the 0. The left bound, you can move the cursor. You could type in points. I move the cursor. I get negative 1.5, so that's correct. I check the second point. I'm doing the 0. This looks like it's 5, so I'm going to check it. My left, when it says left bound, I'm going to type in a 4. Enter. When it says right bound, I'm going to type in a 6. Hit enter. When it says guess, I hit enter. And it's 5. So I know those both are correct. That's it for this video. I'll continue the rest of these notes on another video.